Far beyond Earth, in a region of space nearly 1 million miles away, a remarkable observatory drifts silently through darkness. Protected by a giant sunshield and equipped with the most powerful infrared instruments ever sent into space, the James Webb Space Telescope spends its days collecting ancient light from the deepest reaches of the universe. Its mission is simple in concept, yet extraordinary in practice. Look farther than any telescope before it. Look deeper into time. And reveal what the universe was like during its earliest chapters. Every image Webb captures is more than a photograph. It is a message from the past. The light entering its mirrors today may have begun its journey billions of years ago, long before Earth existed and long before the Sun was born. When astronomers study that ancient light, they are not simply observing distant objects. They are investigating cosmic history itself. For decades, scientists developed models describing how the universe evolved after its beginning. According to these models, the first stars formed from vast clouds of hydrogen and helium. Those stars eventually gathered into young galaxies. Over time, gravity pulled more matter together, allowing galaxies to grow larger and more complex. It was a gradual process. Or at least that was the expectation. When James Webb began sending back observations of the distant universe, astronomers expected to see small, primitive galaxies struggling through the earliest stages of development. Instead, some of the objects appeared surprisingly bright and surprisingly mature. Several distant galaxies seemed far larger than researchers anticipated. Rather than tiny collections of newly formed stars, these systems looked like well-developed structures already containing enormous amounts of matter. The discoveries immediately attracted worldwide attention. Scientists began asking difficult questions. Had galaxies somehow formed faster than expected? Were stars appearing more rapidly in the early universe than current theories predicted? Or were the observations revealing something entirely different? To answer these questions, researchers turned to one of astronomy's most powerful tools, spectroscopy. Every star emits light. But that light contains hidden information. By separating light into its component wavelengths, astronomers can identify chemical elements, estimate temperatures, measure movement, and even determine how far away an object may be. In many ways, light acts like a cosmic fingerprint. It carries clues about the environment from which it originated. When scientists analyzed the light from several distant galaxies, they found evidence suggesting intense periods of star formation. These galaxies appeared to be converting enormous quantities of gas into stars at astonishing rates. If the measurements prove accurate, it would mean that some regions of the early universe experienced dramatic growth much sooner than expected. That possibility is fascinating because stars play a crucial role in cosmic evolution. The earliest universe contained mostly hydrogen and helium. Heavier elements did not yet exist in significant quantities. Elements such as carbon, oxygen, silicon, calcium, and iron are created inside stars through nuclear reactions. When massive stars reach the ends of their lives, they release those elements into surrounding space. Future generations of stars then form from that enriched material. Eventually, planets emerge. And under the right conditions, life becomes possible. In a sense, stars are the factories responsible for creating the ingredients needed for everything we see around us today. If stars formed rapidly during the universe's youth, then cosmic evolution may have progressed much faster than scientists once believed. However, astronomy rarely delivers simple answers. The farther researchers look into space, the more difficult observations become. Distant galaxies are incredibly faint. Tiny measurement errors can sometimes produce large differences in interpretation. For that reason, scientists approach every surprising discovery with caution. Additional observations are essential. Independent teams must verify results. Alternative explanations must be considered. And new data must be gathered before strong conclusions can be reached. This careful process is one of the strengths of science. Unexpected discoveries are not immediately accepted or rejected. Instead, they are investigated. They are tested. And they are examined from every possible angle. As more Webb observations accumulated, astronomers began building a clearer picture of the young cosmos. What emerged was a universe that may have been far more active than previously imagined. Galaxies appeared to assemble rapidly. Stars formed in tremendous numbers. Massive structures emerged surprisingly early. Rather than a slow and orderly progression, the early universe may have experienced periods of intense activity and rapid transformation. These findings have inspired researchers around the world. Some scientists are refining existing models to account for the observations. Others are exploring new possibilities involving galaxy formation, dark matter, and cosmic evolution. The goal is not to discard decades of scientific understanding. The goal is to improve it. Throughout history, major discoveries have often begun with unexpected observations. The realization that Earth orbits the Sun changed humanity's view of the cosmos. The discovery that galaxies exist beyond the Milky Way expanded the known universe. The detection of planets around distant stars transformed our understanding of planetary systems. Now James Webb is contributing another chapter to that tradition. Its observations are providing an unprecedented view of the ancient universe. Every week brings new discoveries. Every observation reveals new mysteries. And every mystery pushes science forward. The most exciting aspect of Webb's mission may not be the answers it provides. It may be the questions it creates. Questions about the first stars. Questions about the first galaxies. Questions about how the universe became the vast and complex place we see today. As the telescope continues its silent journey through space, it gathers more ancient light from ever greater distances. Some of that light has traveled for over 13 billion years before reaching its destination. Now, for the first time in history, humanity possesses an instrument capable of examining those ancient signals with extraordinary precision. And somewhere within those distant beams of light may lie discoveries that reshape our understanding of cosmic history forever. The universe still holds countless secrets. James Webb is helping us uncover them, one photon at a time.